Hi everybody, good afternoon.
Good afternoon.
Welcome everybody, and today we are resuming our discussion on data structures and algorithms. You'll be soon receiving an assignment. So in today's class, I'll also be telling you how the assignment format will be and how you will be submitting it, etc. Let's start with the course content first. First, in the last session, we saw about stacks and queues. We saw stacks and queues, and today we will see something related, which is called recursion. You might have heard the name. You might have heard this name quite often, but let's see what exactly it is. So in recursion, you can basically recursion means a function calling itself. When a function calls itself, that becomes a recursive call or a recursive implementation. Let's say you want to define factorial of a number. It's a common example. So how will you define it? Factorial n becomes a recursive call is equal to 1 into 2 into 3, so on up to n, right? N minus 1 and then n, where n is an integer, right? So this is how factorial is defined. Recursion means a function calling itself. Now you can define a function, define factorial n, and you can say here my output, let's start with 1, and then you will say for I in range n, right? So basically I'm just writing a rough program. There may be edge cases which this may not be able to handle, but just a quick implementation. Output. Okay, so now it should not include 0, and it should go up to n plus 1. Okay, n plus 1. Start from 1. So output equal to I into output. Right? In this way, this loop will run, and then you will say return my output. Something like this, right? Another way to implement this thing will be if you write n factorial as n times n minus 1 factorial. So my n factorial is equal to n multiplied by n minus 1 factorial. So see, this is factorial n is equal to n times factorial n minus 1. So this is how we are writing it. But then there is one. So what I would call this as the base case, or the recursive case. Like, this is the basic definition. Recursive definition, right? And then this should terminate sometime, right? Because you can keep going to n-1, n-2, so on, so forth. But where should it end? That end condition has to also be, must be also stated. So the base case is 1 factorial is equal to 1. This is our terminating condition, right? So basically, you can keep going in this way until you reach 1, and you know 1 factorial is equal to 1. Because otherwise, if you don't tell what is the end of this loop, then it may go into infinite loop. It may go into negative numbers, and then it will keep decreasing, and it may go into a basically infinite loop. So this is what is the terminating condition. Now you start with any n, it will go down to factorial 1, and it will. So how you write a recursive function? To write a recursive function, you will say define factorial n. Should we not write a program on the? Let me write it on a Jupyter notebook. Go to the Jupyter notebook. All of you know how to turn on a Jupyter notebook. Okay, there was a question last time. Okay, we will be discussing it. Anyway, so let's now do recursion. So what is recursion? Let's say we define the function vector. Are you able to see my screen?
Yes, sir.
Factorial n. Now, what we will be doing here is we'll be defining the function itself, which is so this is basically return n into factorial n-1, right? So it should return n times factorial n-1, right? So this is a general case, the recursive case, but then this will go into an infinite loop, right? It will keep, let's say you put, let's say I call factorial 5, then it will go to 5 minus 1 is 4, 3 2 1 0 minus 1 minus 2, not stop. So let us put a terminating case, and terminating case should come before, so that it can terminate as soon as it is found. Terminating case could be if n equal to 1, then return 1, right? And if n is not equal to 1, then it will return this thing. Okay, so that's it. This is recursion. 120. It returns the right answer. And if I input here 2, it will return 2 into 1 is 2. If I input 3, it will return 3 into 2, 6. So in this way, it returns the correct answer. Now, okay, there can be edge cases. Somebody may input Other things, let's say maybe main integer and may pass a non-integer. If n is not an integer, then this will go into trouble, right? The program will fail. It will go into some infinite loop. Let's say factorial 3.5. Now see, this has gone into an infinite loop. I have to stop it. How do I stop it? Maximum recursion depth exceeded in comparison. So basically it went into an infinite loop, but then it has some automatic cutoff. So the program is able to find out that there has been some problem and it's an infinite loop. So it terminated on its own, but it was a problem actually.
Sir, can it return the value of 0 factorial, this program?
Pardon?
0 factorial.
Yes, and that is another problem. That's another edge case it cannot return. So we have to put here, if n equal to 0, then return 1, because 0 factorial is 1, by definition. And then if n is not an integer, then it should give an error, right? So what can we do? Assert n is an integer. Basically, n is equal to integer of n, which means basically n should be an integer. And otherwise, it will raise an error. N should be, right? Anything else left? Okay, somebody may pass a negative number. That should also be taken care of here. Assert n is greater than 0 or greater than equal to 0. N should be positive or non-negative, basically. It can be 0 or positive. Non-negative. So these are the edge cases which we are handling, but the main meat or the main concept which I wanted to tell is this. There is a base case or a terminating case, and then there is the normal recursive case. So now it will not give error. Now see, it gave an assertion error and should be an integer right from the beginning. It is 5. Okay. And you can, whenever you can break your function in terms of smaller functions, which is basically a same function calls itself with a smaller input, then recursion is useful. Okay, now let's look at how the recursion actually executes in the memory. Okay. So what happens is, whenever we call the recursion function, it creates a stack. Let's say, let's use a simple code, factorial n. So if n equal to 1, then you break, or you say return 1. And otherwise, you are returning. Okay, please keep yourself mute. That helps to focus on what we are doing. Return n times factorial n minus 1. Right? Let's say this is our function. How it executes in the memory. So what happens inside the memory means you don't have to do it manually, but it's important to know what exactly is happening inside. Internally, it is using a stack. Means the program execution automatically uses a stack. So what it does, let's say you encountered the function factorial n, which let's say with 5, factorial 5. So your n has a value of 5. Your n becomes 5. And it goes to this statement, n equal to 1. No, n is not 1. So here it says you have to return 5 times factorial 4. So you are standing at this statement where n is equal to 5. And let's say let's give line numbers 1, 2, 3 line numbers. So you are line 3. Now this whole thing, now you have invoked another function, factorial 4. You have invoked. So this thing will be put onto a stack. this thing is put on a stack. This is my stack. Okay, I left something there. Okay, so this is put on a stack. And where does your program go? It goes to another function, which is factorial 4. Now it goes to factorial 4. Okay, let me leave it like that. Factorial 5 was here. And within this, it called factorial 4. Now this here is my execution is happening here. So here my n is 4, and it calls factorial 4 times factorial. So it basically goes to line 3, but with n equal to 4. And it leaves this thing on the stack, and then it makes a transition to the new function called factorial 3. Now in factorial 3, again, this condition is not met. It again calls, okay, then all the variables, the current variables and the line number these are saved on the stack, and you enter the new function. So now here n, the variable n is 3, and you are at line number 3. And then this, you enter the new function factorial 2. In factorial 2, this condition is not met, this condition is met. So 2 times factorial 1. Again, now you are going to another function, so basically this thing will be put on the stack. N equal to 2, line 3. And now you are calling factorial 1. Now when you reach factorial 1, this condition is met. So you will return 1, right? And when you returned 1, now this function, it returned 1. It came here. Now here, again, it will go to this stack. So this thing is pulled off, or this thing is popped out. This thing is popped out. So this is executing line number 3. So it has to return the value of n, which is 2, times the value of this function, which was returned as 1. So this thing now is evaluated as this thing. Now what next it has to do is it has to return this value. So it has to return 2 now. So it returns, where does it return? So this goes away. Now this one is popped out. When this one is popped out, line number 3, return n, which means 3, times factorial n minus 1. This function was returned by this as 2, right? And similarly, it keeps on going, and basically you pull off things from the top of the stack, and ultimately this is 3 into 6, 4 into 6 is returned, and then here 5 into 20 is 24 is returned, and then finally it is returned. There is nothing on the stack, so all the program has been executed, and finally it returns 120.
So can you explain how the popping started? Just the initial part.
How the popping started? See, it executes the program, right? It executes the function. Whenever you are seeing another function being called, then this whole thing is put on the stack, and your execution cursor, you can say, it enters this program with the new set of variables. Like n has a new value, and all the environment, or all the variables, basically local variables, they get new values. And yeah, and then how the popping starts, let's say here it executes this function without invoking any other function. Now it has to return 1, right? It came, n was 1, it returned 1. So now this function is over, right? As soon as you hit the return statement, this function is over. So it will go back to the stack and pull out whatever was on the top of the stack and start executing there.
Okay, sir.
So whenever the function is complete, then only it will pull from the stack. Okay, so here it is using stack. So recursion uses stack inside the memory. Okay, right. If that is clear, then I would like to take a slight detour and I will go to a question which was asked in the last class. I had saved it as a Jupyter notebook, and again I forgot today, but then this reminded me. Okay, the question was asked, what is call by value and call by reference? And does Python do call by value or call by reference? So the answer is this. Call by value means, okay, let's look at this function only. Let me make it bigger. Let's look at this function. So this function, what you are doing, you defined some function, function of some object, let's call it obj1 also, no problem, obj1. So what I'm doing here is I am just, obj1 is a list and I'm appending an entry to the list. That's the simple function, to append a new entry to the list. Now I'm running my code. I define a new list which has some entry, and I'm printing the value of the list, which is Ram only. And then I execute this function on this object. But see, okay, generally what I would do is I will say obj equal to this, and I will return the obj1, right? That's how I will do generally, right? So this function takes the obj1 as the input, it modifies and then returns that object, and then this object is saved as this obj variable, and then you see that thing has been updated, right? But now what if I don't return something? This function does not return anything, and I don't update it. Now see, I am passing this obj, but I'm not updating the obj. Will it be updated automatically? That is the question. So even without, okay, let us take obj as something else. Let's take it as, instead of a list, let me take it as a number, right? And I pass this number to this function, and what this function does, it just adds 1 to that number. What do you expect now? Before function and after function. What will it print before function? Let me. So before the function is executed, the value of obj is 2. After the function is executed, what will be the value? What do you expect? Okay, let me make it simple. So what will be the value after the function is executed?
3.
3.
3, sir.
Yes, it is 3. Now let's say I don't return this object. I just do it like this. Now what will be the value?
2. 2, sir. Should be 2.
Yes, it is 2. So what happens is, this is called call by value. So when you came here, this function, you are passing obj. So what is it passing to the function? It is passing a value. So it does not pass the variable or the reference to that value. It just passes the value. So imagine that you have a container in which the value is stored, and you have a reference to that container. Let me draw it on my notebook. Let's say you have a container which contains the value 2, and then there is a reference to it called obj. And this is in the visible world. This is your coding world. You have a reference to obj. Now, what are you passing into your function? If you are passing the reference, so this is my reference, the reference or the pointer or whatever you call, and this is the value. This is the actual value. Call by reference or call by value. If you're doing call by value, then you pass this value into your function. It does not modify the obj. But if you're passing the reference, then this place itself is updated, right? Am I clear or am I confusing you? inside the function, if I'm passing the value, then I will just copy this value to some new variable, which could be obj1. Obj1 also gets the value 2. This also obj1. So basically a new variable is defined here. Sorry, I'm a little messy in writing. So when I call obj1, then it will create a new variable called obj1 inside the function. And this has the same value. The same value is passed here and it becomes 2. Now, whatever operations I'm doing, I am modifying this value, but this value is not changed. So this is unchanged. This is called call by value. Now, what is call by reference? So call by reference means, okay, let me do it here. Call by reference. It means I have a value, I have some function, some reference called obj. It refers to some value. Let's say 2. Means, okay, this is not Python now, but let me just, or maybe let us call it as a list 2. Now this is my reference and this is my value. Now when I call function obj as, let's say, obj1, what happens is it creates a new obj1, but since this was called by reference, so this obj1 will become same as this obj, basically, which means I am pointing to the same content, same values. So now inside this function, it is pointing, it was called by reference. So this reference was copied here, and this pointer or this variable contains the same data. So if I modify this data, then after the function is executed, even if the function didn't return anything, still your value in the main program will be affected. This is called by reference. Do you understand it now?
Yes,
is it
sir.
clear? Okay, thank you. So now the question is, does Python do call by value or call by reference? So the answer is, it is a little complicated. This is how the language is designed. You cannot do anything about it. It is just internal to Python. So it does call by value for immutable objects like numbers, strings, tuples. If you're passing these things, then any modification you do inside the function, it will not affect your variable here. But if you are passing some mutable objects like lists, etc., then it will actually modify your value here as well, because it is called by reference in this case. This is how Python works. It does call by value for immutable objects and call by reference for mutable objects. So when you're writing your programs, be very careful that if you're passing some array to a function, then this array can be modified by the function, and you are even outside the function, that changes, those changes will reflect. So that's what you have to be careful about. Is that clear?
Yes, sir.
Yes, sir.
Sir, so like C, we cannot pass a number as call by reference in Python, right?
We cannot pass, no. So you have to update it. You have to return. You cannot pass an integer.
Okay, like address of integer, like in C we pass, but in Python we cannot do that.
Yeah, yes.
Okay.
Okay, so is that clear? Should we move to the next topic?
Yes, sir.
Okay, so the next topic, let me change to the now the next topic we are going to study is trees. Okay, trees. So you have understood the concept of a node, right? What is a node? A node contains some data and then some links to other nodes, right? N number of links are possible. And you saw this concept in linked lists, where each node had it could be singly linked list or doubly linked list. But who limits the nodes to be connected only in a linear list? It can be connected in a non-linear fashion also, right? So this trees is an example of, these are examples of non-linear ADTs. Non-linear ADT. And the concept is something like this. You have a node, and then you have children. This node has got children, and each child can be another node. And it can have further children, it can have further children. So this is the concept of a tree. Now you see, the data is not linearly arranged. Right? There is not single line or single order, but this is non-linearly arranged. Basically, from here you can go to either here or here. From here you can go either here or there. So there are multiple paths possible, right? It's not a single chain. That's the concept of a tree. So to define it, it's a collection of elements called nodes. This is the collection of nodes. And so here one of the node is called root. The first node, which has got no parents, this is called a root. And then there is a hierarchical structure of nodes. So this is called this is the parent, and this is the child. This is the parent, this is the child. Then if you have more here, then they can have their own children. Like this one is the parent, and this one is the child. This one is the parent, this one is the child. So every parent can have children. So in this way, you can have a complete tree. Now the constraint is that a child cannot have two parents. A child can have only one parent. And of course, root has no parent. Root has no parent, that you know. A child can have only one parent. That's it. It cannot have two parents. A more general data structure will be called a graph. In a graph, it can have any number of connections, and it's just this one can have this, can have this, and it can again be connected to some other nodes, can be connected like this. I mean, there is no constraint in more general data structure called a graph, but we are discussing trees, not graphs. So we'll not discuss graphs, we'll discuss trees only. In trees, this is the constraint, that if you start from the root, there is exactly one way to reach any node. There are no multiple ways. Only single way is there. Only single path to a single child, to any child. And then leaf, there's a concept called leaf. A leaf has no children, no child. So let's say finally you reach this node, which has no further children, then this node is a leaf node. So root node and leaf node. These are two things. Just a terminology to refer to some important concepts. So there are multiple leaf nodes, but only single root node. Okay. Now, so you understood the concept of node, you understood the concept of root and leaf, you understood the concept of parent and child. Now, if two children have the same parent, they are called brothers and sisters or siblings. They are called siblings. So this one, so I wanted to draw with a different color pen. This one and this one, they are siblings. These two are siblings. And then what is a path? A path is the concept of path. This is the connection from parent to child, and it is unidirectional. Basically, it goes only in one direction. So let's say if I ask you, is there a path between this node and this node? You'll answer yes. Let's say if you start from this node, you go up, and you reach this node. So there is a path existing. But if I ask, okay, let me give them some numbers, 1 and 2 and 3. Is there a path between 1 and 2? 1 and 2? Yes. Is there a path between 1 and 3? Yes, you can go here, this way, it is there. Is there a path between 2 and 3? The answer is no. Path has to be unidirectional. So if you go up, you cannot come down. Or if you come down, you cannot go up again. So path is unidirectional. And so in this way, the path is defined. Okay. Now,
Sir?
yes?
So the path between the node 1 and 2 is unidirectional or bidirectional? I mean to say we can go from 1 to 2 as well as from 2 to 1.
Okay, means what I mean to say is that it should not reverse the direction in between.
Okay, sir. Okay. Got it. Thank
You
you.
do not do like up and then again down. That is not possible. If you're going up, then keep going up. If you're coming down, then keep coming down. Generally, the trees are defined in this way, that your nodes are defined in singly linked list. Singly linked nodes are there mostly. Like this node will contain address of the children nodes, but children node will not contain any pointer to the parent node generally. So generally you start from the root and traverse in downward direction. Okay. Now there is a concept of ancestor and descendant. So 1 is an ancestor of 2, right? Because it is parent and parent. So it's an ancestor. So 1 is an ancestor of 2. And 3 also. Ancestor of 2 and 3. And 2 is a descendant of 1. So basically 2 and 3 also. 3 is also a descendant of 1. Okay. This is the concept of ancestor and descendant, basically. Now, there is a concept of height of the tree. So what is the height of the tree? Height means starting from the root node, going to the deepest leaf node. How many connections are there, basically? So 1 and 2. This tree has a height of 2. The deepest leaf node is at a depth of 2. Similarly, you can define in general what is the depth of a node. The height of tree. This is single value for the entire tree. Depth of a node. This means if you take a path from the root to that particular node, then how many links are there? Let's say you take this node. The depth of this node is 1 because the path from the root to this node has single link. So 1 is the depth. What is the depth of this node? Node number 2. The answer is 1, 2, 2. So the depth is 2. That's it. This is the concept of depth of a node. Then finally, we have a concept called a subtree. So this thing is called a subtree of so this is a subtree which is a child of root node. And the subtree means basically the node along with all its children. This node along with all its children. This is a subtree. And for this subtree, this is the root, right? That is the concept of subtree. Yeah, these are all the terminology associated with trees.
Sir, a subtree contains only parent and child, or can we have more? Like if two had some children and three had some children, then
Yeah, yes. So that subtree means the node along with all its children and descendants, etc. All the descendants basically. Yeah, you're right. So let me draw a more general case. You have a so in this way. So if I ask you this node, so this is a subtree. Where this is the root of that subtree. And this is the main root of the entire tree. Oh, sorry, root. This is the root of the entire tree. Okay, so that's it. Okay, so these are all terminology. So we will be using these terms now later to define our, also basically for different purposes. Let's define a simple tree called a binary tree. What is a binary tree? In a binary tree, every parent or every node can have up to 2 children. In a binary tree, each node can have up to 2 children. Can have either no children or 1 child or 2 children, but it cannot have more than 2 children. That's the binary tree. Basically, it's like this. This is a binary tree because every node can have up to 2 children. And in a binary tree, you can define the node like this. So you'll say class node. In the node, what are the variables? There is something called self.data or self.value, anything. Let's say I'm just initializing it with 0, but it could be anything. Could be none also, anyways. And self.left. There are 2 children, left child and right child. Left is equal to, let's say, none, and self.right equal to none. That's it. So this is a node of a binary tree. Now, you want to define a tree, then you will simply say, oh, should I? Okay, let me. I can do it in the notebook also. That will be more efficient. I can then show you some experiments also. Share. Tree. You can define class node, and inside this node, you can define all the variables. Self dot value equal to, let's say we can pass the value here also. self dot left child is none. Self dot right child. And now here I can, that's it. Yeah, that's it. This is one node. Okay, now to define a tree, I can say root equal to node some information, maybe some value 2, then root dot left equal to node some value maybe 3, then root dot right some value node 5. That's it. So I've defined a tree, but this won't print the tree for you. To print the tree, you have to write a function. You can write a function here which will print the tree. Okay, but that's how we will define. Okay, now if you want to define, okay, so let me write something on my notebook. So here basically what is happening is you have the root variable which points to the root of the tree. And if you want to reach any node, then you have to go via this variable only. You will say root dot left, you will come to this node, then again dot left, this node, root dot right will this node, root dot right dot left, root dot right dot left dot right, and this node. In this way, you will access every node. All right. It looks like a complicated thing, but let's see how do we traverse the tree in an efficient way. So the next topic is very important topic. It's called tree traversal. This is one of the most, I found it tricky, tree traversal. It's very helpful, very useful, especially for those of you who are doing programming in graphs, etc. Tree traversal is very useful. Okay, so there are 3 kinds of tree traversals defined. One is called pre-order traversal. I'm just defining the names first. In order and post order. What does this mean? Let's take a tree. There is a root node. Let me call it as N is the root node. N is the reference to this, so it's not the data. And then it has got some children. I am representing each child as a subtree. Basically, each child will have its own subtree. No? So I'm calling it T1, T2, so on up to some TK. So there are K children of this node, and each child has its own descendants, and we are putting everything as a tree. Now, what happens in the pre-order traversal? In the pre-order traversal, what happens in the pre-order traversal? You first operate on the root of the tree, number one. Well, basically first you visit the root of the tree and do whatever operations you want to do. Let's say you are searching for some value, right? So how will you search for some value? First you come to the root, you search here. So first, number one, root n, right? N is the root node of T of the tree T. Let's say this is the tree. Then you go to the T1, then you go to T1 and then traverse it in pre-order. Now see, this is a recursion. This is a recursive statement, right? That you are doing pre-order of the whole thing. And it says, first go to the node N, do whatever the operation, then go to T1 and do the traversal, pre-order traversal of T1. And then you go to T2 in pre-order. And then T3, etc. T3, T4 up to TK. I'll give an example, but let's do the in order thing now. It's very similar. So what happens in order traversal? So you do the same thing like this. But what you do here is, first you do T1 in order. You do a traversal of T1 in order. Then you do traversal of, or basically, then you do the root node. And then you do T2 in order, followed by T3, followed by T4. It's everything in order up to TK. Then what about post order?
So is there any advantage of doing this like first you order then root and?
I will come to that. There is an advantage, yes.
Okay.
Now what happens in the post order? So in the post order, you will do T1 in post order. Then T2 in post order. Followed by T3 in post order, T4 in post order, so on to TK in post order. And finally, you do root N, the node N, root node N. So these are three kinds of traversals possible. Let's take an example to see how we actually do them. I'll draw the example here. This is an example. Let's say you have a tree A, a very simple tree B, a C. So now tell me, how will the pre-order traversal look like? So you first traverse A. Let's say here traversal is just printing out the values. It is not doing any comparison or anything. It is just printing out the values. So you will print the root node A first. Okay. So first A is printed. Then you go to T1 and do the pre-order traversal of T1. So which means you print the root B followed by its children. There are no children, so only B is printed, right? And then the pre-order traversal of T2, which is again C is printed. So this is the order you do. Print A, then B, then C, right? Now tell me, how will the in order traversal look like? Yes?
B, A, C.
You go to T1, so first B, then you go to root N, that A, and then you go to other trees, the other children, then C. How about the post order?
DCA.
B, C, and followed by A. B, C, followed by A. Right? This was very easy. Let's see more complicated trees now. You have a tree A, B, C, D, E, F, G. Now tell me, how will the pre-order traversal look like? Okay, just the mnemonic to remember. In pre-order, N comes at the first. In order, N comes in the middle, means left, root, right, and others in order. And in post order, N comes at the end. So all the left, right, all etc. Finally, N. So in pre, N is in the pre. In order, N is in the middle. Post order, N is at the end. Okay. Now tell me here, how will you do the pre-order traversal of this particular tree?
A, B, D, E.
Okay. We will do A followed by a pre-order of this subtree.
B,
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 then D, D, then E,
E,
then
and then
C,
C,
is over. Now we go to this one. So
C,
F,
F, G.
Now, how about the in-order traversal?
So
In-order traversal.
B, D, E.
D,
Okay. So yeah, you will make a mistake here. So let's do step by step. First, in-order traversal of this subtree, right? So in-order traversal of this subtree B, B, E, right? Followed by the root node A, followed by in-order traversal of this subtree CFG, right? Now expand it. This is equal to how much? What is the in-order traversal of this?
D, B, E,
D, B,
B, E,
then
E,
A,
then A,
then
F,
F,
C,
C, E.
so it's like this. You make this arc first, this arc, then this arc, and then this arc. Basically, you do arc by arc. If you see DBE, then A, then FCG. Okay. Now let's do the next one, which is post-order traversal. How will you do post-order traversal? So basically, the root will come at the end. So this is equal to post-order of B, D, E, right? Followed by post-order of CFG, followed by the root node A. So what is this equal to? This is what post-order is?
EEB.
D, E, B, then
F,
this
FG.
F, G, C,
F,
G,
G, C, followed by A. So you see, the order is quite different, right, in every case. But all of them are doing a valid traversal of the entire tree. Okay. Now you see this one, the first case, in order traversal. So see, what is the order? It is DBE. It goes to the deepest node D. I'm sorry, this one. Sorry, this is the pre-order traversal. Look at the pre-order traversal. So what happens here is you are doing A, B, then D. So you go to the deepest node on the left, the leftmost deepest leaf, and then you go to the next E. And then again go to the depth wise, you go C, F, and then you go to the next level G. So basically it's also called depth first search. This pre-order traversal is also called depth first traversal or depth first search. Generally, tree traversal is used for searching. That's why you will see that these terms are used synonymously, either traversal or search. This is the depth first search, or in short, it is also called DFS, depth first search. So so imagine you are looking for some solution. So what you will do, starting from the root, you will go to a very deep point. It can be very, very deep. And then you go to the next deep point, leaf, then the next deep leaf, next leaf, next leaf. So in this way, you are traversing the whole tree depth-wise, or first you go to deepest point, then deepest point, then deepest point. On the contrary, another way is you do breadth first search, where you do first at this level A, and next level you will do BC, next level you do DEFG. That is another actually traversal. It's called level order traversal. Here you do level by level. This is generally, this does not use stacks, or this does not use recursion. This traversal is not based on recursion. So, but what it does is it does level by level. Like the traversal will be here ABC only. A, B, C, and for this one it will be A, B, C, D, E, F, G. A, B, C, D, E, F, G. This is called level order traversal or breadth first search, or BFS. Breadth first search, BFS. These two are very popular methods of traversing your solution. For example, if you are confident that your solution is somewhere nearby only, it's not very deep, then you will do a breadth first search, so you can quickly find your solution without wasting too much time. Or maybe it is possible sometimes your tree is infinitely deep, right? In that case, you will never go for a depth first search because your tree is infinite and your depth first search will just never come back. It will keep going down and down. So in those cases, it is helpful to do breadth first search. But of course, there are other cases where depth first search may be more useful and breadth first search may not be efficient. For example, if a node has got like so many children, maybe very large number of children, potentially infinite number of children, then BFS is of no use. Rather, you would like to do DFS. So anyways, depending on the use case, you have to choose which one you want. Okay.
Sir, in binary tree, then BFS is better. Can we say that?
No, it depends on the application. If you know the solution is close to the root node, then you will do a BFS. If you know the solution is very deep somewhere, then you will do a DFS.
Sir, if tree is sorted, then also BFS will be more beneficial, right?
We will come to the sorted trees. If tree has got some kind of structure, we will come to those kind of trees a little later. Such trees are, okay, a common kind of tree is called binary search tree, which is sorted in some way. I'll discuss it a little later. But good point. Yeah, that the utility of tree is that it is very efficient for sorted data and it can do it very efficiently. It can traverse or find out your data very efficiently. As you have seen in the previous examples, that if you are searching for something, if you know everything is sorted in some particular fashion, then you can very quickly do the search, right? order log n. The big O complexity is log n. Okay, so that's it. Now let's look at the codes. How will you program the things? So
Sir, please give an example for non-binary tree.
for non-binary tree, yeah, sure. Okay, I can give another example. Okay, this is a non-binary tree. Let us draw 1, 2. So this is a non-binary tree. Here you have got 3 children. Okay, how will you do the pre-order traversal for this tree? So in your pre-order traversal will look like this. You will first do the left child. First you do the root node, then first child, second child, third child, right? That is the order. Okay, let's do the root node. Root node is 1. Then this subtree in pre-order, which means 2 only. Then this subtree in pre-order. This means 3, 5, okay, 3, then 5, 8, 9, right? I'm just putting brackets here just to tell you how things are progressing. Right, 3, then 5, 8, 9, then 6 and 10. And then you go to the next root, 4, 7. Right, this is basically depth first. So no? 1, 2, 1, 3, 5, 8, then 9, then 6, 10, then 4, 7. So it's breadth first or depth first search or depth first traversal. What about in order? In order means you will do in order traversal of this subtree. It is single node, so I can rightly test 2 only. Then the root. Then the in order traversal of this whole tree. In order traversal of this 3, 5, 6, 8, 9, 10. Followed by in order of 4, 7. Which means, so how will this expand to 2 and 1 are remaining the same? Then what is the in order traversal of this? So in order of this, then 3, then in order of this. What is the in order of this? 8, 5, 9. Then in order of 3, then 6, 10. Am I doing it correctly? Okay. There is a there is a problem here. Okay, I think I should have drawn it like this. So this is the first child, right? So this is basically the left node only. There is a confusion. I'm sorry. I should not have caused that confusion to you because this is not a binary tree. So there is no left and right here. It's all like this. Right. So it's 6, 10 is here. Okay, so 10 and 6 here. First child and 6. And then here you have got 7, 4. This is the in order traversal. Is that clear? Is it becoming too confusing for you?
It
Yes,
is
sir.
clear.
Okay. Okay. Post order, I will leave it to you. You can do it.
So basically, we are breaking the bigger trees into binary trees.
We are breaking the
Bigger trees into binary trees.
no, not necessarily. There is no notion of binary tree here. It's a general tree. Means it could be n-ary tree. Okay.
Post order will be 289,
Okay.
289, 5, 10, 6, 3, 7, 4, 1.
2, 8, 9, 5, 10,
6, 3,
6, 3,
7, 4, 1.
7, 4, 1. Yes. Yes. So it is 2, 8, 5. Sorry, 8, 9, 5. Yeah. 10, 6, 3, 7, 4, 1. Post order. Yes. This one will be done at the end. Yeah. Yes. You can do it in 2 steps. That will be more clear then. Okay. Yeah. Anybody has any questions until now? Okay, let's write the programs for them now. Programs are very simple because once you understand the concept, coding it is not difficult. And you can clearly see it's a case of recursion. Very easily you can do recursion. So I will say define the function called pre-order. And what is the input? Input is the root node. And in general, it is any node, could be root node or the root node of the subtree. So pre-order traversal starting from the node, this node, right? So what we will do, it's a recursion. So first we will put the terminating case. What is the terminating case? The terminating case is, let's say if the node is none, then you don't do anything, right? That is the terminating case. If node is none, then you just return, don't do anything, just return. But if the node is not none, okay, now the recursive case. So here you will first traverse the root. Let's say we are just printing the values. So here, whatever function you are doing that you write, whether it is printing or searching, whatever, I'm just printing. Print simply node dot value. And then you will do pre-order of the left node and then the pre-order of the right node. That's it. And that's it. It's over. Right? Or you can add a return at the end. That's understood. Yeah, so basically if your node is none, that is the terminating case. And if your node is not none, then you will do first do the current node, then the left tree or left subtree, then the right subtree, and that's it. This is the very simple program, pre-order traversal. Now what will happen if I do the in-order traversal? Nothing much will change, just these 2 statements will change, right? You just exchange. In-order traversal, just that this statement will come in the middle. That's it. And in the post-order traversal, this statement will come at the end. I'm sorry. Basically, this statement will go to the end, right? That's it. That is the post-order traversal. Is that clear?
Yes.
Yes, sir.
You can write simple programs to make the whole thing, but that's the thing. Okay. So anybody has any questions you can ask? Otherwise, I will. Oh, actually, I want to show you something. Let me show it to you. Just a moment. So in this, I will be sharing an assignment with you, and how you will be doing the assignment. That will be okay. Okay, let me quickly do it, and then let me show how the assignment will look like. I have to open my Python notebook. Let's do it very quickly. Okay, stop it. Just a moment. Okay, so the assignment which I'll be sharing with you will look something like this. Let me do screen sharing. How do you share? You'll see this file, your roll number .ipnb. There are some general instructions like you have to write in Python 3, etc. This is the question. This is a simple question which I took from Lead Code, the website I showed you. So this is the question, and this is how the solution is. And write your code here, and you will get 10 marks if you write your code here. Now you can add more classes and more functions also, no problem. But just that, do not write any statement like this. Let's say sol equal to solution, right? Don't do like this. But if you want to do like this, you do if underscore name equal to name. So what I'll be doing is, there is a setup, there is a program to automatically evaluate your program. Let's say this function, yeah, let's do it. It will take 10 minutes hardly. Okay, so return true. Let's say this is, I wrote some function and I wrote finally this function returns some value, return true. Now I'll be testing this function, right? So I will write a test case. Define test underscore. I will be passing a function. So equal to solution sol dot is valid. Is this a valid bracket? So this is a valid bracket. This is a valid, this is not a valid bracket. If the brackets don't close properly, like if you see in this case, the square bracket closes first and then the round bracket is closing. But whereas square means this is not a valid bracket, right? This is the question. So yeah, that's it. So if this is valid, yeah, assert, or you can say if this statement is passed, then print OK. And here you can say, oops. Okay, so it prints okay, because this is trivially, it is returning true for every case. That's why I'll add another statement here. Let's say this, print error. If your program returns true for this also, this means program has some error. So it returns error. Okay, basically this is the setup which we'll be using, and I'll discuss more about it maybe in the next class. I will share this assignment with you and all the instructions with you, and then still if you have some problems, some questions, then you can write to me or put it in the forum. I will ask the TAs to explain the whole thing to you. This can be done by TAs also. Okay, thank you very much. Do you have any questions? Any questions? Yes? No? Okay, so fine. See you on Friday. But before that, you will be receiving the assignment very soon. Thank you.